All right. Hello and welcome everyone to the Algorand Proof of Stake Show, a show by algo devs for algo devs. Here we connect with the development teams building out our decentralized future. We're focused on the devs, exploring design decisions and the code powering the projects and protocols within the Algorand ecosystem. I'm your host, Ryan Fox, developer advocate here at Algorand. On today's episode, we are focused on the developer experience. My guests are colleagues with me here at Algorand, Ann Kenyon, Director of Product, Jason Paulos, Senior Software Engineer, and Andrew Choi, Software Engineer. The developer experience is a paramount concern to the Algorand ecosystem. Great dev tools like AlgoKit, Conduit, and our various language SDKs combine to form the basis for application development on Algorand. Today, we look at the changes found in Release 3.16, which will greatly improve your development experience during design, testing, and debugging. You will learn how to time walk in dev mode, use the simulate endpoint to track down a bug in PyTail program, and learn how group resource sharing will allow you to design more robust applications on Algorand. We've got a lot to cover here today. Anne, Jason, and Andrew, welcome to the Algorand Proof of Stake Show.
Great to be here.
Glad to have all of you back as repeat offenders, in fact. So wonderful that you are willing to come back on the show. And you're sporting a new title. Can you tell us about your new role and what you've been up to since last we spoke?
Sure. Yeah, it's been a few months since the box's release, I think.
Right.
Yeah, right. I'm now Director of Product, which means I get to decide everything, right?
Nice.
No, I'm joking, but it just means I have a broader view on everything that we work on at the Inc. Not just, I was previously mostly focused on just the smart contracts platform. So now I'm also involved in the performance work and state proofs, things like that.
Wonderful. Very good. So do you get to arm wrestle Paul over what goes in? Is that how this works now?
Yes.
All right. Can't wait to have Paul on to refute that. Very good. All right, Jason, warm welcome back to you as well. And
Thanks, Ryan.
Algorand recently celebrated a couple of milestones. Can you share a bit about each of those?
Yes, just a little over a week ago, we actually celebrated our 4th consecutive year of mainnet, and that was a pretty big milestone.
Absolutely.
And pretty close to that, we also had our 30 millionth block on mainnet, which is another very exciting thing.
Those are both great milestones for Algorand, for the mainnet, all of those without any downtime, which I think is just unheard of in this industry. So, well, congratulations, Algorand. Andrew, release 3.16, which we are going to focus on today, went live on mainnet just yesterday, a handful of hours ago. So what are some of the exciting things that you found in there?
Yeah, it was super exciting because I got to kind of contribute dev mode timestamps, but also, we now have 3.3-second block times, which kind of pushes us up to 10K TPS.
Right.
Super exciting.
Absolutely. Those are some big little numbers as well, you know. Like, I mean, the faster we go, the more transactions per second we can have because we still have the same number of transactions available within the blocks, but we're able to have more blocks within that shorter amount of time. So therefore, TPS goes up. Nice. 10K, big number. All right. And so we're going to talk today about the developer experience. So I wanted to ask you, why is the Algorand developer experience important to your teams?
Well, I'm pretty sure we're addressing developers today, so I maybe don't need to tell them why it's important, right? I make your lives easier, or we make your lives easier. You can build things faster, build things easier, build better things to grow the Algorand ecosystem. I mean, it's really a no-brainer to me that a good developer experience gives Algorand a good reputation, makes people want to choose Algorand. Look, it'll be faster to get your app to mainnet on Algorand than anywhere else. So it's totally worth it to invest in this from our perspective.
Wonderful. Well, glad you are doing that. Glad you guys are all here to show us around a little bit about what these improvements are. So, Andrew, are you willing to kick us off and tell us a little bit about what is dev? What are the enhancements that you have for us in dev mode?
Yeah, so first I'm going to kind of show off this new feature called kind of timestamp control in dev mode. And I'll start with a very quick motivation. Why do we really need to control timestamps? Well, it's a very popular feature in other blockchains. Think of Ethereum and developer tooling related around that. And it's also a fairly highly requested feature on Algorand. And it's because smart contracts often require timestamp interactions, and devs don't want to wait around real time, thousands of seconds to test time sensitive features like time locks, auctions, pools. So in this release, we made this possible by providing this sort of AlgoD API to set timestamp offsets just in dev mode. And by setting an offset, you can effectively set a constant difference or a delta between consecutive block timestamps, which gives you the superpower to fast forward time with ease. And that's what I'm going to demo here today. So if you can see my terminal screen here, I'm going to be using AlgoKit for this demo. So if you haven't already, just please update your AlgoKit. So you can do that by AlgoKit localnet reset -- update. And just make sure that you're on the correct build version. So we're currently on 3.16.3. So I actually have the extreme latest version here. And with my network setup on dev mode, so I will also just show you that I am on dev mode here using DockerNet v1, using a private network. Yeah, we're ready to kind of show you this demo. And for this demo, I'm actually using a very kind of standard template. So if you are familiar with the Python SDK, we recently added this examples folder. So in this examples directory, we have a set of templates, kind of boilerplate programs that you can use to interact with Algorand using the Python SDK. And I very slightly modified this program called the overview.py. So overview.py basically gives you an overview on how to use the AlgoD client using the Python SDK and try to fetch things and send transactions with it. And I just modified that so I can demo timestamps here today. And at the end, I just added maybe 10 lines here just to showcase what you can do with dev mode now. So the top part here, again, just to clarify, we initialize an AlgoD client, and then we get the accounts. We make sure that we have some sort of funded account. And then we create, send, and wait for a transaction in this helper method that I created right here. Very simple, we're just sending transactions, and we're going to inspect the block header to make sure that our timestamp offsets are being set properly in dev mode. So here I'm just going to run this timestamp overview.py. And you'll see that I have some output here. So just to kind of give you a better idea of what I am printing out to the screen. So what I'm doing first is I'm using this set timestamp offset method that is available on the Python SDK, the latest version. And I'm setting it to this constant, just a string of ones. And then we have this new utility called getTimestampOffset as well, which basically queries the AlgoD and makes sure that you're on dev mode first, and then your offset is being set properly. So after we set this timestamp, we send a transaction, and then we kind of query the block info. I'm going to show you. So this is what a block header contains. And there's actually another bonus feature here. You can see that in DevNet, we didn't use to populate the block seed. But now you can see that our block seed is also populated, which means that you can also use certain teal opcodes that utilize this sort of seed property in blocks. And the second thing is that you can see that we have this thing called timestamp. So it is abbreviated as TS. And you can see that we can actually set this timestamp offset to be a certain value. So I'm just going to try to send another transaction here. And you're going to see that the timestamp actually increases by whatever offset that we set in dev mode. So this obviously makes it a lot easier and a lot kind of closer to the real thing, even when you're using dev mode. You can control timestamps with these. And I'm going to change it to 9s. And you're going to see that the timestamp is going to be incremented by 99999 instead of the standard string of 1s. And if we change this to thousands, oops, you'll see that the timestamp increases by set amount that you want as well. And with this, we really hope that devs can use this sort of feature to create sort of tests that are really similar to real networks. And yeah, we're very kind of excited to see what other things you can build using these testing utilities as well. And hopefully this can make your lives a lot more easier. And for command line enthusiasts, you can also curl this endpoint. So I have a short example where you can, for instance, query algod using curl, and you can get the offset that way as well. And I think that's it. I'll pass it back to Ryan.
All right, very good, Andrew. We appreciate that. I love how you throw in a little command line for us as well at the end, right? Interesting the way to do that. So the demo there that you had is just based on what we find in the SDK, correct? Based
Right.
on what we find in the examples.
In the examples folder, I added around 10 lines. I can also show, maybe I can publish in a GitHub repo, but yeah, it's basically copy and paste and added a few more lines at the end right here.
All right, very good. Appreciate that. All right, well let's head over to Jason. I think Jason, you've got some demos to show us about the simulate endpoint. So maybe remind us, right? We've had simulate for a while, but what are some of the enhancements that you're bringing to us and why?
Yes, that's right. Thanks, Ryan. Yeah, there are essentially 2 new capabilities of the simulate endpoint in this latest release, and they are going to be able to allow us to both increase the amount of logs that a smart contract can produce and increase the amount of opcode budget that a smart contract can use. And of course, just to kind of remind everyone, this is possible because simulate, like it kind of sounds like, it simulates the transaction, but it doesn't actually commit it to the chain. So we have a lot more flexibility and freedom with the operations that we're able to use with simulate. And I'm going to show you today how we can use those to help find and fix a bug in a smart contract. And so to do that, I have a PyTeal contract right here. This is a contract that just contains one method. It's called array contains. And really, we just want to know if this array, this first argument that we pass in of uint16s, contains this target value. And we want the result to be true if the value's in there and false otherwise. And so we really, the way that we're going to do that is we have a binary search method in here as well. And this is going to be doing the heavy lifting of attempting to find that target element that we're looking for. And if it is in there, we'll return the array index. And so this condition right here, or sorry, if it's not in there, we'll return the length of the array since there are no negative numbers in the AVM. And that's how we're going to know. Basically, if the number that we get back is less than the length, we know that that value is in there. And so I will quickly just show you the binary search routine that we have in front of us. Let's see. If you've written a binary search before, this should be kind of nothing new. If you were to ask ChatGPT to produce a binary search algorithm, it might produce this exact one. And I'm not going to go into detail too much at the moment, but basically, we have a low value, a high value, a midpoint. We get the value at that midpoint. And if it's the value we're looking for, we've done it. So we return the index. Otherwise, we'll change our low value or our high value to try to narrow in on where that value could be. And I guess I just will mention very quickly, this array that's being input is an ordered array. That's kind of a prerequisite of this function. Okay, so we have this binary search implementation in teal, but how do we know if it's actually working? Well, I've written a few tests to help us figure out if it's working, if it's doing its job properly. I have this app client class, which actually does kind of the heavy lifting of setting up the smart contract and doing the boilerplate kind of information to set up the sender and the signer and to actually call it and simulate it. But all of that gets exposed in this nice array contains method on that class. So we should be able to run these two test cases and hopefully they'll pass. As you can see, we've got the numbers 1 through 5 here. We're trying to see if 4 is in this array. We expect that to be true. And if we try to see if 100 is in that array, we expect that to be false. So I will run this for us right now. And as you can see, the test case passed. So we should be pretty happy with that. However, I want to do kind of a more advanced test just to make sure that there are really no bugs hiding anywhere in this program. So I've written some additional code that's going to make us kind of a more powerful test. So what we're doing here is we are going to create a random list of a bunch of numbers between 1 and 2 to the 16th, which is going to be the largest value that a uint16 can hold. And this array is going to be 998 items long, which is the longest array we can fit into the application arguments. And so we've got this large random array, and we're just trying to see if the number 0 is present in that array or not. And because the min value is 1 of all these random values, we expect that this should be false because 0 just can't be in there. Okay, so let's try to run this test case and see if this passes. And it helps if you save your file before you run it again. And unfortunately, I see some red, and it says logic eval error, subtraction would result negative. Okay, so that's definitely an unexpected result from this test. And so now we have to try and debug what went wrong and how we can fix it. And so let's see. Normally, in a conventional language like Python or Go or JavaScript, it can be really helpful to add print statements to various places of your program just to print out key values to see what they are and to see if they match what you expect them to be. And so we can do a very similar thing right here in PyTeal using the log operation. And so if you haven't used log before, it basically emits a string of bytes from your smart contract, and they are observable after you call that smart contract. And so I've written a routine called print int, which we're going to be using to print out a few of these integers. And so I'll paste in here. We're going to print out the key values that we're looking for. So we're going to print out what low is. We're going to print out what high is. Print out mid. And we will print out guess as well. And this should give us some more insight into what is actually happening during the smart contract execution. All right, so let's try to run this test again. Check information. Okay, interesting. So now we have an error that says dynamic cost budget exceeded. And that makes sense because our contract is now doing something else. Not only is it doing the binary search, but it's also printing out a bunch of values along the way. And I didn't show you this before, but printint is actually a little bit complicated because we're converting these integer values to ASCII strings in a smart contract, which is a bit of a heavy operation. And so now by trying to observe what's happening, we've actually changed the behavior and it's using more budget than it used to. So that's a bit of a problem. However, in this latest update, we have some tools to try to address this. And so we can actually increase our smart contract budget to try to account for this. So I have another param here called extra budget, and I'm just going to set this to 3,000, which should be plenty of additional budget to allow our contract to run. And for context, by default, a contract only gets 700 budget. So adding 3,000 more should be plenty. So let's try to run this one more time, see what happens. And well, now we get a different error. Too many log calls in program, only up to 32 are allowed. And that also makes sense. We're logging a lot of things and we're not necessarily trying to log less than 32, which is normally the limit. And as you might expect, we also have a way to raise this to help us get our debugging information. So I can also pass in more logs equals true, and this will significantly raise the amount of logs I can make and the total bytes that the logs can take up from my transaction. And so now we can run this test again, and hopefully we'll get that same error that we got at the beginning about subtraction. And it looks like we do. Logic eval error, subtraction would result negative. Okay, perfect. So now let's look and see if we've logged anything useful. This is the randomly generated list from before. And we also have this new section of logs with these key values from our smart contract that I was talking about before. And let's look at the last iteration here. We've got low is 0, high is 1, mid is 0, and our guess is 21. So let's view that in the context of our program. So the values, and let's start here. So if guess is 21 and our target is 0, this certainly won't be true. So we'll have to jump to the next statement. If our guess is less than our target, which also won't be true because 21 is not less than 0. So we're going to have to jump to the next statement. And what this is doing is it's subtracting 1 from mid and storing it into high. And since mid is 0, and we're trying to subtract 1 from it, it makes sense that this would be a subtraction error because all values in the AVM are unsigned, so we can't go below 0. Okay, good. So I think we've identified what the problem is. And I think to solve it, we just need to add a special case here. If mid is 0, we don't try to subtract from it anymore. We actually just exit the loop because there's nothing else we can do. We can't look anywhere else. The value must not be present. And so I'm going to add a statement before this just to capture that. Else if mid equals 0, then we're just going to break out of our loop because we do not want to execute the next statement. We'll break out, and then we'll just return the array length because the value just isn't present. Okay, so I'm going to save that, and I'm going to run our test again, and hopefully we'll get the result that we're expecting. And yes, looks like it. We have our test passes, and yes, we still have all the information that we were logging. And so we've done it. We've solved the problem. Now I just want to get rid of all of our extra log statements and run it again. So we'll get rid of all of our print statements. We're also going to remove kind of the extra features that we added back in just for debugging. And we're going to make sure that this runs as if it were submitted to a production chain, not with the special bells and whistles of Simulate. And yes, we're still getting pass, and our budget usage is now much more reasonable, around 400 instead of around 2,800 as it was before. And so hopefully, this is going to show you how you can use some of these new features for Simulate if you have a similar problem in your own smart contract. And I will just briefly show you what adding these extra arguments actually did. And it's actually relatively straightforward. This is where kind of the request is actually happening. I have an atomic transaction composer that I create up here. I add my method call, and I call composer.simulate, pass in my algod client, and I also pass in a simulate request. And this is where I'm able to specify these additional options. If I want more logging, I can just pass true for this. If I want extra opcode budget, I just have to specify how much I want. And I'm not going to show this off, but we do also have allow empty signatures that you can pass in if you want to not sign your transactions, but still have them be processed by Simulate. That is also possible. And that is all I have to show.
All right, interesting stuff, Jason. I can see how this will be very helpful for devs to be able to track down bugs in their code, be able to use all of these additional logging features to be able to help them. There are some questions coming in. I think I'm going to hold off to them, and I'm just going to remind folks that are watching live that use the chat feature of your particular platform. They get aggregated here. I'll take them and queue them up for our guests. So, thank you very much, Jason. And we're going to come over to you next. All right. So you've got you're going to share some updates to AVM 9, right? So in AVM 9. We've got some additions to group resource sharing. So I am going to, do you want me to share your screen straight away, or do you want to talk through it first?
Go for it.
Yeah. All right. Here we go.
Yeah.
All right.
Yeah. All right. I don't have a compelling demo, but I'm gonna talk through this somewhat, hairy issue of foreign references in the AVM. So I'm going to start with a brief refresher on what foreign references are. All right, when you submit an app call transaction on Algorand, you have to populate your what we call foreign arrays. So there are 4 of them: foreign apps, foreign assets, foreign accounts, and boxes. And you don't have to populate them; they could be empty, but you often will. And the elements in these arrays, they tell the evaluator which pieces of data it will need to access to complete the evaluation of this app call, which pieces of data from the ledger database. So basically from the blockchain. So like if I need to know something about asset USDC, I need to put the USDC asset in my foreign assets array if I'm going to need it in as part of my smart contract evaluation, as part of that app call. So why do these exist? Because every time the evaluator needs to read a piece of data from disk, from the ledger, it's a little bit of an expensive operation, read or write. So it has to be limited, because if it was unlimited, and one smart contract evaluation could take millions of reads and writes to disk, obviously that could slow down the performance of the blockchain. And this problem is not unique to Algorand, by the way. Every blockchain has to figure out how to manage this resource of reading and writing. And the way that we handle it is through these foreign arrays. So here I have a simple example. I'm just going to talk about assets, but it generalizes to the other types as well. I'm just keeping it simple for this explanation. So in AVM 8 and before, this is how it would work, right? So these 3 transactions are in a group together, but this property is independent from the other transaction in the group. So if I have this first transaction in its foreign assets array has the Pepe asset. So during evaluation, it can access the metadata of the Pepe asset. This one needs access to both Pepe and ETH. So it puts both of them in its foreign assets array. And then at evaluation time, it gets access to both of them. So that's the refresher. And the actual limit, by the way, I don't think I mentioned the actual number, is that across your 4 foreign reference arrays, you can have at most 8 references. And over time, as people started building more and more in Algorand, it became obvious that, like, for some set of use cases, that 8 number was a problem. It was preventing them from building what they wanted to. And one of the simple examples to talk about is, if you're building an NFT marketplace and people are selling art on it, and they want to include royalties as part of the auction or whatever, any sale. So, the person receiving the royalties, their account, would want to get paid out as soon as at the same time as the NFT is transferred. So their account needs to be part of the foreign accounts array. Okay, great, that works. But what if there's more than one person who created the NFT and you want to split those royalties across 10 different people? Maybe there's a musician and a designer and an actual graphics person and the AI. Maybe you want to give the AI some royalty because they were involved, So anyway, that list could grow easily, but because of this 8 limit, you can only handle at most a few people who would receive royalties. So you could never handle something like, a Hollywood movie, right? Those credits are like thousands of people long. So that's a simple example just to show where this can become a problem. But other more complicated examples are, composable DeFi. If you want to find the best swap trade across a bunch of different apps, then you're going to need access to lots of different apps for that one smart contract call. So what did we do about it? We introduced group resource sharing, is what we've been calling it. So in AVM9, which is now live on mainnet, foreign references, so the access to various pieces of data is shared across the transaction group. And so this should feel familiar because it's kind of like, okay, when we didn't have enough opcode budget, we said, okay, now you can share opcode budget across the group. We also introduced fee pooling. Fees are pooled. Transaction 1 could pay all the fees and transaction 2 and 3 could have 0. So in a similar way, here I've set it up so transaction 1 is the one putting everything in their foreign arrays, and transactions 2 and 3 have nothing in their foreign arrays. But now all 3 transactions have access to all 3 of these assets during evaluation. So you can see it. You could now have access to a lot more things by just adding more transactions to your group, and you could potentially add a transaction that doesn't do anything except you're using it to get that extra read and write budget. Hopefully that makes sense. And yeah, what else was I going to say? I don't know. Yeah, I hope that makes sense.
Yeah, well, good. Maybe just on the point. So in the diagram here, so you've set it up so that we are
Right.
in the first transaction, we're putting them all there, but you could have just as easily put it in transaction 1, left it empty,
Right.
along with transaction 2 empty, and then put them all in 3, and therefore
Right, you could have put
still,
1,
yeah.
1, and 1.
Yeah.
Okay,
We
I
all get
remember
it.
what I was going to say.
Yeah.
I was going to say, so I've explained a pretty basic example. There are some subtleties with this group resource sharing that I don't want to bore you by talking about them for 20 minutes, but I invite you to read the articles that we've published on the developer portal that talk about this. There's one specifically about group resource sharing. Because as you may know, certain types, so here, right, when you're accessing an asset, when you put an asset in your foreign assets array, it allows you to access that asset's metadata. So the number of decimals and stuff like that. But if you want a specific account asset balance, you need access to both the account and the asset to be able to get that value. So anyway, there's some subtleties in there that I invite you to go read about in the sort of article and our multiple articles, also the documentation about foreign references has been updated to reflect AVM9.
Right, cool. Yes, and everybody can go to the developer portal, which is found at developer.algorand.org. And then Anne's article is listed up there under the Learn navigational element. And then there is one called Blog. And then you'll see all of the various blog articles. And one talks about group resource sharing. I think you have some links in that article as well to some example codes that you can test it out as well, correct? Usually you
Maybe.
do. Maybe. Yeah, I don't
Maybe.
know. I'm thinking usually you do. So that's why I threw
For
it out.
there's another article that talks about the dev mode timestamp and the simulate stuff, and that one definitely has some code examples for you to see.
All right, good. Well, we really appreciate all of the contributions that you and the teams have put together here for us, and of course those examples on the dev portal as well. So I think it's time for some questions from the audience. So once again, if you are doing the play at home game and you're watching the live stream, you can just use the platform that you're on to type in your question. So if you're on Discord, just hit us up in there. And if you're on the YouTube or Twitch channels, just put them there. To be honest with you, I'm not sure how Twitter works. If you tweet it at me, it goes. So we'll see. But anyway, let's go over a couple of the questions here. So on logging. So this one's probably for Andrew. So when we're thinking about logging, oh, actually, maybe this one's for Jason. Stack element size, right? So the AVM has a limit of that the stack element can't be greater than 4K. So with these changes for logging, can we actually bypass that to actually access a log that is larger than 4K?
That is a good question. Yeah, unfortunately, that limitation, it has to do with just the maximum length of a byte string that you can have in a smart contract. And unfortunately, that's unchanged. That is still 4K. However, you can log that 4K value if you wanted to. Whereas, prior to this, the maximum log length was 1K. So you do still get some more room to work with.
Okay, so we can actually now log the maximum allowable size of
Yes.
of the element on the stack. Okay, so we can't, because it's going to fail ahead of time. So if I was trying to concat something two 4K objects together, the opcode would fail in and of itself, and we would get a different error. Therefore, we couldn't log it anyway.
Right.
Okay.
Right. If you can compute it, you can log it.
I like the way that sounds. All right, good. Thank you for that. Any other comments or that you want to add in there on that one? All right, good. Let's see here. I've got another question here. This one happens to do with timestamp offsets in dev mode. So, Andrew, what happens if you don't set a offset in dev mode? What is your node going to do?
Yeah, so usually the node, it defaults to using a real clock. So it will basically use a real clock for the first block. And then, if you leave it actually dormant, the block timestamp can actually go forward by at most 25 seconds.
Okay.
So that's what you might see. And as soon as you kind of set an offset, it will basically set the next block timestamps offset to the previous one plus the offset. So that's kind of what happens.
Okay. All right. Very good. And are you allowed to change that offset like at any time? Does the node just it takes that?
Yeah. So as long as it's before the block is created, you can change the offset, and it will be reflecting the next block that you kind of create in dev mode.
All right.
Can you set it to 0?
You can set it to 0, and if you set it to 0, the block timestamp effectively freezes. So it'll be constant no matter how many blocks you create.
Meaning that it's going to create a block every single time you do. The timestamp will be whatever time you actually created it at.
Sorry. So if you set it to 0, and let's say your previous timestamp was at 3, then every subsequent timestamp after that will also be 3. The timestamp will be 3.
I see what you mean by freeze now. Okay, cool. All right, let's do that. So looking around for some other questions around here, or if anybody else has some questions that they are seeing as I look through look through
Yeah,
them.
there was one over here. Are timestamps available in logic sigs?
Yeah, so timestamps are in the block header, right? So if you have like a teal program that has certain opcodes that require you to get timestamps, then yeah, for sure you can use this utility in dev mode for that. Some of them are application only, but I believe there are ways to get timestamps in logic sigs as well. So yes.
All right, very good, very helpful. All right, I am looking around and I am not seeing a whole lot of questions coming through here. So I'm going to look at my colleagues here. Do we have any good questions that we want to ask each other here? Any gotchas that we've seen in the, in the little bit of time that we've had this in mainnet, and certainly we've had it in betanet where we've been testing it ahead of time. But anything that devs had come up with and we should let them know about.
Well, do we expect this to, will this all be easy to use in AlgoKit?
Well, I mean, I think it's all available there. So will it be easy to use? I don't know that all the tooling is built in to be able to use this, but I certainly see the value of Simulate. I mean, what will be coming will be the ability for us to just hit the Simulate endpoint and know all of the bits that I'm going to access and just be able to build that transaction foreign reference array. So I think we'll be seeing some enhancements to the SDKs and the tooling within AlgoKit to be able to do that. Yes.
Yeah, and I use AlgoKit for my demo, so it's as long as you use kind of the latest build version, it should be available. But I noticed that some of the interfaces were not necessarily updated, so I don't see it in the AlgoD API column, for instance. But yeah, you could definitely use it if you kind of use it like a sandbox.
Right.
All the new features should be there.
Okay, good. I am still looking. I see one of my colleagues typing in what might be a question, so I'm going to hold off for just a second. So there's a question about AlgoKit for Linux distribution. So AlgoKit is available on all platforms, and the simplest way to install it is just simply pipx install AlgoKit. That way you can download it from the pipx repository on all of them. So we don't have binary distributions, but they are all available through pipx. And all right, well, I think then that I am going to wrap us up here and say thank you all very much for joining us here on the Algorand Proof of Stake Show, where we got to learn a little bit about the Algorand development experience and the enhancements that you have put into release 3.16. So, Anne, Andrew, and Jason, I really appreciate your time today.
Thanks, Ryan.
Yeah, thanks, Ryan.
All right, everyone. So we're going to keep doing these shows, hopefully weekly. We're going to not have one next week. We've got a holiday upcoming, but we're going to come back in a couple of weeks and do some more. So make sure that you follow us along, subscribe to the channel that you're watching within. Check us out on the Algorand Developer Portal. And until next time, have fun building an Algorand.